In this lab tutorial, I will talk about a technique to measure time constant using a oscilloscope. Let's look at a simple RC circuit. At time 0, the switch is closed. So the circuit is connected with the DC power supply. When we look at the transient response of the output voltage, so assume the initial voltage is 0, so it goes up. That's the step response for the circuit. Assume that the switch has been closed for a long time. At time 0 is opened. When we look at the capacitor voltage, it started from the maximum voltage and goes down to 0. That is the natural response of the circuit. So here we can use a square wave to simulate the switching in the circuit. For example, the rising edge of the square wave can be used to simulate that the switch is closed. And falling edge is used to simulate the opening of the switch. So here's the natural response. To measure the time constant here, firstly we need to build the circuit and use a square wave to simulate the switching in the circuit. So let's look at the time constant theoretically. For a simple RC circuit, we know the time constant is just the resistance multiplied by capacitance, 1000 times 0.1 microfarad. We convert it to standard unit. So that is 100 times 10 to the power negative 6 seconds. That is 100 microseconds. So the theoretical value is 100 microseconds. Let's look at how to measure time constant using a oscilloscope. So the first part, we need to use a square wave to simulate the input voltage, the switching of the circuit. We have a resistor, capacitor in series. So these two holes are connected together. This line is connected horizontally. So we need to supply the circuit with a square wave. We use a power supplied function generator to generate square wave. So first we click on square wave, then frequency is 1 kilohertz. For the amplitude, we don't want it to be too high or too low, so let's use 1 volt peak to peak. So we have built the circuit already and supply the circuit with a square wave. The next part, we need to use scope to display the output voltage. So here's a RC circuit. The power supply is here, the red cable and black cable. So the first channel of the scope is connected across the power supply. We want it to display the input on the scope to make sure the input signal is okay. So the output voltage is across the capacitor. We used the second channel of the scope to measure the output voltage. So power supply, channel 1 probe, channel 2 probe. So the next part, we need to measure the rise time or fall time using a oscilloscope. Notice here, we cannot measure the time constant directly. So what we can do is to measure the rise time. So here we just turn on the oscilloscope, auto scale, and then quick measure. We click on, here is the output voltage. Notice we only need to show the output voltage on the scope to measure time constant. Make sure we just disable the input voltage. we need to adjust the scope display. Here we want to measure the rise time, that is the rise time for the step response. So we can adjust the frequency of the power supply to make the display look better. So adjust horizontally. For channel 2, we adjust it vertically. Quick measure. Then we can select rise time. So here we pick up rise time. Then we measure rise. So after we select that, we click here to measure rise time. Let's zoom in to see what's the rise time here. So the rise time is 208 microseconds. Now we need to calculate the time constant based on the rise time. Let's look at the transient response of the RC circuit. So the maximum voltage, we use Vm indicate the maximum voltage. The rise time is defined as the time when the voltage goes from 10% of the maximum amplitude to the 90% of the maximum voltage. So here is the rise time, the time spent when the voltage goes from 10% to 90%. We can measure rise time directly with a oscilloscope. The time constant can be derived as the rise time divided by natural log 9. So natural log 9 is 2.197. Is equal to 2.197. So the rise time is 208 microseconds. Time constant should be rise time divided by natural log 9. So we can calculate is 95 microseconds. Percentage error here we can define as measured minus nominal over nominal. So the measured value is 95 microseconds minus 100 over 100. That is negative 5%. So let's review the steps to measure the time constant. Firstly, we build the circuit and use a square wave to simulate the switching of the circuit. The second part, we use a scope to display the output voltage. Notice here, we only need to display the output voltage. Do not show the input voltage on scope when you measure the time constant. Otherwise, we cannot get the correct value. Then we measure rise time and fall time. The time constant is rise time or fall time divided by 2.197. Here, I also want to mention that the power supply frequency should be reasonable. For example, if the frequency is too high, when you look at the natural response and step response, so the output voltage didn't get enough time to reach its maximum. So that's when the frequency is too high. So we cannot measure the time constant correctly. When the frequency is too low, so you will see that that is how the display looks like. So it's kind of hard to measure the time constant accurately if the frequency is too low. So here, we really want a good display of the natural response or step response on the scope. So we can adjust the input frequency.